Time to solve Project Euler, problem number 11. So I already spent 2 hours, at least 2 hours on this, and I'm not going to subject you to that video. I got caught up in several gotchas, and I just want to give you a quick summary of where these things bit me. I still don't have a working solution to it, so we're going to start from the beginning together. But the first one was that I decided to try to use the Windows function. I just discovered the Rust slice Windows function. So what this does is it gives you a sliding window over the elements of a slice. So I also committed the use of Windows to replace some handwritten arithmetic in problem 8. And I think this is much nicer for a few reasons. One is that it saves you from arithmetic errors. The Windows does the right thing, and you don't have to worry about where the actual indexes of the bounds are in the slice. And another is that it indicates the intent. So this is, okay, somebody's doing some math. You'd have to stare at this for a while, maybe to figure out what was going on, or it would need a comment. Whereas Windows gives a pretty concise explanation of what's going on. It's something somebody may be familiar with already. There's good documentation for it. And thirdly, if somebody does come to this code and doesn't already know what's going on, and they have to learn about the Windows function, it's not maybe as nice as them already knowing the Windows function for them, but at least they'll walk away knowing something they didn't know before that will be useful in other situations. Whereas if they take the time to dig through your arithmetic and they figure out what's going on, that does them no good at all on the next problem. They are now experts on this one piece of code. So I think this is better. So I tried to use it for Project Euler number 11, but I got into an issue with the borrow checker, where the windows themselves were trying to capture parts of the grid and weren't living long enough. So I think I kind of know what was going on enough to try Windows again now with you, but it cost me a good 20 minutes just messing with it. So of course I gave up eventually and went to just handwritten arithmetic and had an off by one error, which cost me, I don't know, another 20 minutes to debug. So once that was done, I eventually had this thing implemented in a way that seemed to work, but my answer was not being accepted by Project Euler. You can see down here, you must wait 26 seconds before submitting any more answers because I already submitted a wrong answer. And it seemed to be doing the right thing. I couldn't figure out why my answer wouldn't be taken, and I think I've figured it out now. So they say here, so the problem is, let's go into what the problem is. It says, in the 20 by 20 grid below, 4 numbers along a diagonal line, and they show you this diagonal segment, have been marked in red. The product of these numbers is something. What is the greatest product of 4 adjacent numbers in the same direction? Up, down, left, right, or diagonally in the 20 by 20 grid. Okay, so you can see maybe where Windows would be useful. So I'm going to try this adjacent 4 and then this adjacent 4. You can just slide a window through along each row, through each row. You'll have to do it through each column, right? The top 4 and then so on. And then diagonally, I did diagonals that are parallel with this. They've presented diagonally here as though it's a direction on par with up, down, left, or right. But I don't think that's what they mean. I think they mean 2 directions. I think they mean diagonal going down and diagonal going up. So that's what we're going to try now. And one more suggestion for how this problem could have been presented better is the red numbers. The numbers have been marked in red. It would be awfully nice, and I say this as somebody who's red-green colorblind, if they didn't just rely on the color red to call these numbers out. There's nothing inherently visual about this problem or the concept of diagonal numbers or selecting numbers within a matrix. So why impose this requirement for this particular ability that people are sighted and can see the color red or can distinguish these colors? Okay, so let's do it. We're going to copy our starter boilerplate to Euler 11. And we're going to replace all the places that says Euler with Euler 11. Cool. I'm going to copy the text here, the exercise, into the module level doc comment. Module, create, file. I guess module, because the files are basically modules in Rust, right? Okay. I want to indent this as a code block. also want to find a better way to call these things out. Obviously, because I don't want red to be the requirement, especially if I want to keep this plain text or just a code block. So these are it's the 26 up here to the 14. You can see over 26, 63, 78, 14. So I'm going to put an empty space above, and let's put a little extra space to the sides. There, and now you have a kind of center block. I'm going to add a note. We'll use maybe square brackets to show that this wasn't. It'll be a hint that this isn't part of the original problem description. We'll say the red numbers are the downward diagonal 26, 63, 78, 14 shown in the center. Downward diagonal. Because the numbers are listed afterwards. Diagonal of the center. Center. Okay, good enough. Okay. So let's say test. Yeah, good. Euler 11. Okay, unreachable code, yada yada. So our plan, I think, is going to be first of all, I'm going to get rid of this test because it's just annoying me that we have the noise over there. Fine. We will add a test, however, for we'll make some test data, and then we'll need some functions that can call that test data. For now, I'm just going to get rid of superstar. Just commented it out. So we'll say in here, I think the algorithm is going to be, we will take there are two basic ways you could slice up this problem, right? One is that you go through the entire grid, and for every index, you find all of the products, the horizontal product starting from there, the downward product, the downward diagonal starting from there, and the upward diagonal. And one downside of that is that from any particular pair of coordinates, you might not have enough. So for example, if we get over, we'll have to consider starting from here, starting from, let's see, this would be index 18 if that's index 19, right? So this is column 18 and row 0. So from row 0, column 18, there's a vertical window, but there's no horizontal or diagonal window because it would go off the edge of the grid. So we have to have parts of our code that are either in if statements or helper functions that return options that we'll have to combine. Whereas if we make, I guess it's going to be 4 separate passes now through this loop, through this grid, because we're going to need to loop through all the horizontal windows, all the vertical windows, all the downward diagonal windows, and all of the, like the one that they've shown here, and all of the upward diagonal windows. But for each of those separate loops, which we'll probably put in helper functions, we can make them correct by construction because we know what ranges of indexes are valid start points for those. So that gets us out of a lot of checking on a per element basis. If this were a really huge grid, then probably I would leave in the checking just to avoid having to make multiple passes. So it's a weird thing, right? If you have a small grid, it doesn't really matter. If you have a big enough grid, then it matters to the performance of the program because you want the cache locality. Once you've taken the time to load part of the grid into cache, you want to do everything you're going to have to do while it's there, and don't worry about the CPU cycles. And then when you get big enough again where it's not going to all fit on a single machine, then it's nice to actually be able to parallelize again. So you kind of want the 3 separate passes because you can do them all at the same time on different machines. But I'm going to do 3 passes so we can make it correct by construction. Sorry, 4 passes. So what we'll need is the max horizontal. And we could hard code this whole grid as just a module level variable, but it makes it harder to test. It would be nice if our functions, our individual helper functions, can all be passed separate grids just for test. So let's say, let's make a We're still going to need this whole grid though as a variable. So let's say grid, or we'll call it rows since it'll be an array of arrays. That rows equals, and we'll need these numbers again. I'm going to get rid of the comment markers, get rid of the blank lines. We'll need to get rid of those empty columns there I made too, or extra spaces, I guess. Goodbye. Goodbye. Okay, so now each of these spaces becomes a comma space. Oops. Globally. There. The ends of these are going to become close square bracket, comma. The beginnings are going to become left square bracket. Cool. All right. Oh, okay, so I just ran Rust format, and it kind of screws up the grid because it really wants to fit everything into 100 columns. And does it fit in 100? It looks like it fits in 100 columns. Anyway, so what I do usually is I have a vertical line here to show me where I would have gone too far. I wonder why Rust format wants to break those up like that. It's not trying to fit them in the right number of columns. By the way, I also like to keep things to 79 columns when we can. This is 89, so this is going to be a little bit bigger, but that's okay. In general, though, it's nice to fit stuff in 79 in a way that Rust format will respect. In this particular case, I think we need to override it. I'm going to say Rust fumt. I had to look this up earlier. Skip. That's apparently how you do it. Okay. Max horizontal not found in this scope. Yeah, cool. Just get rid of that for now. U64 found unit. Oh, right, because we need to return a number. So this is going to be to do. This is intentional. Prefix it with rows. Cool. So what we're going to need is, I think, max horizontal. It'll have to pass the rows. And we'll need to pass the window size as well. This is another oddness. Let's just do this for now. I want to get, so what we're going to end up doing is say max horizontal, take the maximum of that with max vertical, so that'll go through all the vertical windows, dot max with max diagonal, which actually is two different directions. We'll get to that, of the rows. Okay. So now we're going to need these functions to be defined. Oops. Yeah, okay. So let's get rid of these two for now. And we'll declare max horizontal. Max horizontal. You'll have to take the rows. You could say that this is going to be an iterator of things that give you iterators, but it's nice and simple if we make them arrays, and then we can use that dot windows method on the slice. So I want to do that. So we're going to say this is going to be an array of, let's make these U8s. This is an array of U8. Oh, sorry, it's an array of arrays of bytes. This is how many? 20, right? 20, 20. Oops. Yeah, good. Because these fit in bytes. And again, it would actually be easier for us to use U32 because the window size is 4. So we have basically up to 99 to the 4th power would be the biggest possible product we could have, right? Which is that. Which is cal string, which is less than 100 million. So that would fit handily in a U32, but not in a U16. So U32 is probably the right size for our products. We could just make this whole grid U32 so we don't have to cast anything. But again, whenever I have a grid of numbers like this, or just a huge collection that's going to be in memory in RAM, I'm having a hard time justifying wasting 3 out of 4 bytes in this thing. They're just not going to be used for anything, right? In the storage, it would be 0 byte, 0 byte, 0 byte, 8, 0 byte, 0 byte, 0 byte, 2. So let's just make them bytes. And byte is spelled U8 in Rust. Okay, so we have that. We're we're going to have this thing is going to be, we'll take it by reference, or we'll borrow it. 20. Oh, no. So I could say this. It's actually an array of those 20 wide. This will return AU32 because that's the product type. To do rows. Yeah, it needs to be passed a borrow, a reference. Okay. What exactly is the difference between a borrow and a reference? I think of this thing as a reference, meaning it's basically a pointer that doesn't have an address in its own right. Where if you take its address, you get the address of the pointed to thing. But I know people refer to these as borrows. Okay, so expected U64, found U32. Where did U64 come from? Do I have a... Oops, U64. Oh, because from our boilerplate, we were using U64 for everything. Let's use U32 for this one. Okay, cool. Not used. So the issue with this is, again, now we've hard-coded the size of the input array. And I don't want to do that because I want us to have tests. I want us to have some nice small tests. In fact, let's go ahead and add a... First, I'll mark this the underscore. Yeah, running 0 tests. Let's make a test. I don't want to have to test with this whole thing because to check whether this is giving us the maximum horizontal window, we would have to go through this whole grid and compute it, which seems like a pain and error-prone and time-consuming and not really necessary. So let's just take this little center that they gave us, and I'm going to copy it, and I'll go down here into mod test, make some space for it. There we go. And we'll say this will be our test grid. Const test grid will be an array of byte arrays. They're 4 wide, and we have 4 rows. Again, open square brackets, close square brackets. Okay, dead code. Cool. Use super. That should complain. Yep, because we're not using it yet. So what we're going to do is define test, function test, moon, test. In the output, I would love it if we had some better convention than calling the module test and calling the function test, because it's already marked as test. So in the test output, you're going to see, if it fails, you see test. I'll show you what I mean in a minute. This is to test max horizontal. So there we go, super. We're not using it. So we'll need assert equal max horizontal. We'll call this. I'm just going to put 42 for now. Argument of yada yada is missing. Oh yeah, we need our test grid. So we're going to pass in our test grid. Okay, so this is expected 20 and found 1 with 4. So this is the first of the issues I've promised to tell you about of why I want to do things a little differently than this is because now we can't easily pass in our little test grid. So instead, these are going to be what Rust calls const generics. I don't know why it calls them that, but they're just constants that you pass as parameters to a generic function or to a generic type. So in this case, we're going to have our width, and this is the syntax. Usize, const, usize. You just have to put const in front of it, and then you give it a type. This apparently gets confusing to the compiler because it thinks that that W is a type and usize is a trait that W kind of extends. So here we go. Cannot infer the value. Why can't it infer the value? Where is that? Line 61. Here it can't infer the value. Oh, because I haven't given it any there's no way for it to constrain W. So I'm going to replace these with the, let's see, this will be the width, because this is the row type, because we're row major order, right? Row major, meaning when you index into the rows here, you're going to get which row first, and then the second index you give will give you what column, which is why I've called this rows. If you were in like MATLAB, it would be column major order by default. I think R is column major. I could be wrong. So H. Yeah, good. Failing the test. Now, we're also going to need to pass the window size, right? Because part of our problem definition is that the windows are of length 4. Where is it? 4 adjacent numbers. Not 4 directions, even though they've listed I've listed 5 things here, up, down, left, right. That's really 6 directions. But 4 adjacent numbers. So we need some way to get the number 4 in here. We could hard code it everywhere, or we could declare a module level constant, right? We could say len usize equals 4. But it feels like, since we're passing everything else as parameters to the function, that's how we would do it. And I, with my, I guess, broken C++ brain, would have thought the thing to do, let's make L the length of the window. We'll add a comment at some point. Like this. Cannot infer the value of parameter L. So yeah, of course you can't. So I would have thought you'd call that, and then if we were in C++, it would be like this. You'd say 4. And I know in Rust you do this. But the problem with that is, forgetting about this one, 4, let's say. The problem is supplied 1 generic argument, expected 3. You can see here, it really wants you to pass. It's happy, you saw a minute ago before we were passing that, it could infer W and H from the test grid, but it somehow loses that ability if you explicitly pass another one. I don't know why that is. I don't know if it was a policy decision to be explicit. I don't love it. I'm hoping that this is a thing that will get fixed. It's just a quality of life issue, where if this were C++, that would work fine. It may also just be that this error message could be a little bit better, because what I think is the best thing to do is actually not to pass it like that, even if a C++ template meta programmer would have thought so, like myself. What you would do in Rust, I think, is instead just pass it as a const parameter. And I think that I haven't tried making this whole function const, but it's possible that the whole function could be const, which is what C++ calls const expr, Rust calls const. Okay, now type usize is missing. Yeah, good. So now we're gonna look down here at. I'm gonna make this font just slightly smaller so you can see the line numbers and the end of the code. Yeah, good. Oh, actually, you know what else we can do? We can just take this. I'll drag this thing over. I think it gives us enough room to make this a little bit wider for the error messages. All right. So where was it? Max horizontal. Oh yeah, here it needs that, and it's going to be 4. All right, good. And then in the test, it needs to be 4. Help this. This is yeah, len is not used. Fine. So 33. Let's leave it like that for now. All right, now let's figure out for our little test grid, what should this thing be returning? Well, it's going to be the maximum of these values, right? So let's see. Let's turn these all into multiplication statements. And I'm going to call debug for each of these. And let's do cargo run dash bin Euler 11. Not yet implemented. Where's our not yet implemented coming from? Oh, in max horizontal rows is where it's coming from. Yeah, so forget that. Let's try that again. Okay, so here are the products of the rows. The biggest one, it looks like, is this guy right here, 219411010. 219411010. Okay. Terrific. Okay, oh, dead code. Just uncomment that again. Okay, and it's failing with main panic that not yet implemented. Perfect. Let's implement it. In fact, before we do, I just want to try returning a value here. See that it fails. Excellent. All right, so max horizontal. So what I figure we'll do is we'll go through each row of the grid and use windows to slide across all of those 4-element horizontal windows. So we'll say rows. Rows is a rows is a rows is a rows. Dot. What are we going to do? For each of these, we're going to get I have this thing returning max horizontal. We're going to end up calling .max, and .max is going to return an option, and then we're going to have to call .expect. Oh no, or we can just return options. All right, we'll get to that in a bit. But I think we're going to hit an issue as we iterate and then try to take the maximum value, because max returns an option in case you gave it an empty collection. And we have not guaranteed here that that this collection will not be empty. Yeah. Okay, so I don't think. Can you have empty arrays in Rust? I guess we'll either return an option here or we'll use some .expect calls. So rows, flat map, because it's going to be a nested loop, right? We're going through each of the rows, and then within each row, we're going to need to take all the windows. So row, in here we'll need row dot windows. This is the whole point, is we got the slice here. Len. So now len is used. And over that, we will need to take an iterator. And that's going to give us bytes. And our product is not going to work, I think. Let's try that. Rows is not an iterator. Rows is a rows is a rows is a rows. Iterator. Method not found in Windows. Whereas this one is already. Windows gives you an iterator. Cool. Expected U32. Found flat map. Right. Rows dot windows. What am I doing? You can't take the product of the windows. We'll need to take, for each of these windows, we'll need to take dot map. That's why we need a flat map. Win, I'll call this. Product, it'll be win. Yeah, there we go. Iter dot product. Okay. Expected U32, found flat map. Because this is an iterator. So now we need to take the max. Yeah, this is the issue, is that max returns an option. So do we want max horizontal to return an option? What do we want to expect? I think, you know what else we could do? We could return an iterator over the products. And then the max call will be in the calling code. Because an iterator can just naturally be empty. Let's do that. This is going to be an impl of iterator that we're returning for some type that returns U32s. Okay. Right. Okay. So this will be, instead of max horizontal, this will be, what will this be? This will be horizontal products. Sounds like a company that makes mattresses, right? Like Sleepy's, Tempur-Pedic. Welcome to horizontal products. Max horizontal. So max horizontal, all the max horizontal. Well, then we're going to have to call max everywhere we use it. Yeah, all right. You know what? We're going to keep... yeah. Okay, so we'll say horizontal products dot max dot expect grid should contain at least one window, because that's the only way, as if there was no grid. Right now, it's if there's no horizontal grid, but at the bottom of this, it's going to be of any kind. Okay, let's try that. Max horizontal, yeah. Okay, so now also horizontal products. Oh, here. We actually don't need to expect here. Horizontal products, so we can just change our test function to expect an option. Option is not an iterator. Oh, is that what I had? It's not an iterator. Line 36. Oh, because max, I'm still calling maps. There we go. Flat map should be impl iterator. A trait product is not impl. Yeah, okay. So this is the other problem with the bytes, right? So win.iter. Let's say let window values equal win.iter.map byte. And that'll be by reference, I think. Byte as U32. And we'll say window values dot product. Is that right? Okay. Block is empty. You might have not meant to close. What? Block is empty. You might have not meant to close it. Oh, meaning I might have closed it accidentally. Yeah, okay, let's get rid of that. You might not have meant. That is not super idiomatic. You might have not meant to close it. I wonder where that is. Do I have the Rust source code? I would love to submit a patch for that. Rust. Oof. Must be big. Might have not meant. Yeah, you might have not meant to close it. All right. So that is in, it's in a few places. Oh, I bet one of those is a test. Not meant. You might not have meant to close it. Okay. Might not have meant to close it. Might not have meant to close it. This sure looks like it's supposed to be the expected output for a test. I'm not sure how you run the tests in this. But for now, I am going to check out a branch at grammar. Order. Rephrase error message slightly for idiomatic English. Idiomacy. Error message to be idiomatic English. Rephrase diagnostic to be more idiomatic English. Get remote -v. Do I have a fork? I do not have a fork. All right, I'll do that later. So, window values. Okay. Yeah, so I had this thing not closed. So closing delimiter possibly meant for this. Unclose delimiter. What do we have here? The iterator. We have our flat map. We have our map. Okay. We have a block of code. Bada bing, bada boom. This should close that. Oh, and then we have to close the flat map. Okay. Hidden type for infiltrate captures lifetime that does not appear in bounds. Yes, because the iterator depends on rows continuing to exist. And we have a nice anonymous lifetime there. May outlive borrowed value len. Right, because len's a parameter to this function, meaning it's a local variable. So this has to be move. So it'll take the reference and the length. Equal. Okay, cannot be applied to type imperator. Oh, yeah. Because horizontal products now does not return a single scalar value. So let's just test the max. And we'll leave this as test max horizontal. We can say test horizontal products max. We'll do that. Test horizontal products max. We'll say let max equal. Oh no, you know what we can do? We can just say horizontal products dot max. There we go. Okay, cool. Hey, we have a passing test. We've been not branching in this project, but I think it's time. These are getting complicated enough that I don't want to be having one big fat commit, and I don't want to keep amending a commit. Euler 11. Implement horizontal products. Euler 11. Okay, no, I don't want to submit a PR. In Euler 11. All right. Oops. I try not to commit stubbed out code like that, or just junk code, commented out code, but so be it. Let us say, let's do the vertical. Let's do, yeah, in fact, this can go dot max. Is it dot and then or dot then? There's a way to have the options kind of collapse, flatten in on themselves. Option. Was it and? I bet it's and. Yeah, it takes another option. All right, so we'll do dot and. Oh, and that's interesting because it means that the max. Huh. So we'll say dot and. Oh no, we need and then. Okay, because we need to take the max of the two, so we need the result of the first one. And then I was thinking that the order doesn't really matter. The order doesn't really matter. They could absolutely happen in parallel. That's okay. And then what did it take? It takes a function of t to option of u. Fine. So this will be the old max. We will say, I hate to say max dot max. And then value dot max. It's not a value in the sense of being an element of the grid. All right, max dot max it is. Max dot max. Max vertical rows. Oh no, we don't have max vertical. We're gonna have vertical products. They must make buildings, skyscrapers, that you can put your horizontal products in. Vertical products, rows 4. Oh yeah, it was still hard code in this 4. Say const window len size equals 4. Let's just say window len. Unclose delimiter. And then, okay, vertical products not found in this scope. Yep, right on. So this is going to look, the signature should be identical to horizontal products. I'm just going to copy and paste this whole function. And get rid of the whole body, rip its guts out. This becomes vertical. Okay. Unit is not an iterator. That is true. Who can argue with that logic? Could you impl iterator? Iterator for unit. So let's, this one's an iterator, right? This is not defined in the current crate because tuples are always foreign. Impl doesn't use only types from inside the current crate. Yeah, I guess it's because we didn't define either the iterator trait or the type unit. Tuples are always foreign. So I guess unit truly is, as it looks, an empty tuple. Huh. All right, so unit's not an iterator. Yeah, good. Why is it unhappy with that? Surprise to do is not good with that. To Okay, the found opaque type. Expect G32 found opaque type. Oh, right. No. Why is it not happy with that? Vertical products. Oh, because we didn't call dot max. Expected G32 found enum option. Oh yeah. Okay, so we have our horizontal max. I'm just gonna call these X and Y. And then we need vertical products dot max dot map Y. We'll call this one Y. Call these H and V. Should we call them H and V? Then we're gonna have the diagonal. I guess that's fine. H V. We'll do H dot max V. Dot map? No. Because this is it's again, and then. Okay, expected enum option found U32. Try wrapping the expression in sum. Sum H dot max. Oh, no, because these are this is dot map. Okay, cool. Help if this is intentional, prefix with an underscore 46. Yeah, okay, because we haven't implemented this one yet. So let's implement this one. So what are we going to do? Up here, let's give this a comment. Returns, here, iterates over all horizontal windows of specify length and in rows. That'll do. All. Iterates over all horizontal windows, turning the product over the product of all horizontal windows of length n in rows. Okay. Over the product of all vertical windows of length n in rows. So here we went row by row. And for each row, did a horizontal slide over the windows. That, I think, is not going to work here. Is it? If we called it, so we'd have to call it, we can't call dot windows. We can call windows on rows, and then we will get sets of rows. So then we'll just have to pluck out the relevant columns. So I guess we can. So what we'll be doing is going down through, right, so it'll be like, these 4 will be in the first window, and then these 4 will be in the next window. But it won't be just the adjacent values. It'll be the whole rows. So let us say rows, windows. We are now officially farther than I've tried with this without your company. Rows.windows. The specified length. Yeah, I found U32, fine. Oh, I know why. I know why this issue was occurring. When we say to do, and it says iterator not implemented for unit. So to do, really logically, to do returns a nothing type. It returns a bottom type, which should fit any type requirements that you have. Bartosz Maluszki has a nice way of explaining this. He says it's like a little game of chicken. It's saying, the type signature is saying, give me an element of your type that meets this this signature. And to do is saying, well, there aren't any elements of this type. Right? It's a tug of war between the type check and the fact that there aren't actually any values of that type. So it doesn't really matter whether an element of that type hypothetically would match the type requirements. But Rust is broken on this, frankly. And I saw a pull request, or not a pull request, an issue filed against it once, and the person who's responsible, or the person who responded, didn't really seem to understand the concept of a bottom type, which is a shame. But it's definitely something we can work around. I don't know. Maybe they've got some point I'm missing, but like I used these a lot in Scala and it worked great. And in Haskell, you can have bottom types and they work fine. And even if you're in C++, you can have something like a throw statement. Or I used to constantly make to-do macros and it works fine. I don't know why in Rust, of all places, which is usually so good about the type system, suddenly bottom types don't work the way that bottom types should work. Okay, so what we are going to have. In fact, I'm gonna go down here and just have my little junk to do thing into editor. Just to have something that meets the type signature to clean up the error messages. Okay, window len. Should have an uppercase name, really? Oh, because it's const. Oh yeah, look at that. Can we make this const too? Oh yeah, how do you like that? Is that any better? Do we have any particular reason to do that? I suppose. Rows, window len. Again, this is like the difference between passing something as a const generic value, as I would have expected, versus passing it as an ordinary const parameter, or immutable parameter, function parameter. And I don't know if it makes any difference here, but I sure like the clarity of saying this is known at compile time for sure, as opposed to something that might not be. That is why I would like this len to also be const L. That doesn't seem to be very well supported. Okay. Unused windows that must be used. Oh, that's interesting. Yeah, and here's, as if on cue, here's something Rust gets uniquely right. Windows, len. So now we have, so presumably we're going to have a flat map again, just very much as we did before, except now we're going to have, yeah, this is going to be window rows, we're going to call this, forgive the long names. Yeah, okay. So now, okay. Oh yeah, this needs to be an iterator just to meet the requirements of flat map. So those window rows, iter dot map. We need them all at a particular column. Yeah, before we were going through we were going row major, and then within each row, we were pulling out selected columns using windows. So now we could just go column major. If we're still going row major, then we just need okay, so let's say that we're going row major still. So we're going to say 0, 2. What's the last one we need? We need this to be the width minus with the grid minus length, and this has to be inclusive. This is the one off by one error I had before. Needs to be inclusive, right? If len were 1, we would want to go up to. Is that true? What are we doing? So we're going to go. We're going to go. Oh no, it's not. It's not the same issue. This is here we need to go all the way across. In fact, because these are the vertical ones. My mistake. Okay, so 0 to W, and in there we're going to map. Oh yeah, you know what we're going to be doing here? We're going to be going. Okay, so we're going to take. First, we're going to start with these, say 4 rows. And then within that, we need to go across. So we're going to take this window, and then this window, and then this window. and so on. And then we'll take the next set of 4 rows, overlapping, right? And we'll take this window, and then this window, and so on. It's a little unintuitive. That's all right. I like the idea of keeping the rows as the outer loop always, so that if somebody's trying to make sense of this module as a whole, they won't be having to keep in mind which order we're iterating through the rows and the columns. It's always the rows on the outside. Okay, so for this, W map. Oh, wait a minute. Yeah. Yep. 0 to W map. And this is basically J. I like to call my column indexes J. I'm going to add a we probably should have been marking these as quotes. So I can also have module level doc. That's not part of that. That's okay. We'll just do this like this, ordinary comments. In this module, the following, this module uses the following naming conventions. We'll say W is a grid width. H is a grid height. Len is a window length. I think that's clear enough. Say I is a row index, and J is a column index. We'll try to keep this small enough that somebody couldn't, if somebody gets confused looking for I, they'll be able to find that. All right, so we could say column index. I'm going to stick with J for now. I think that's clear enough. And I think it's clearer than having a longer name. Okay. So for each of these, we will need the window rows dot map row jth column. And actually this needs to be iter, right? Dot map. We don't have our J is borrowed here. It's already confusing enough that I'm just going to try to get the compiler error messages cleaned up. That'll usually keep me on track. So the issue is, okay, J comes here, right, and then we're borrowing it in this inner closure. So if we take the inner closure and we allow move, good. Okay, flat map that must be used, good. Rows.windows len, flat map window rows. Okay, so that's for each sequence of 4 rows or however many rows. Going across the entire width, we're going to pick out the jth column of just those rows, starting at 0. Good. And then we want the products. So it's that. It's so we need this to be a U32 first of all. We'll just cast that to U32 right there. Then we'll take dot product. Cannot infer type of parameter P. Fascinating. Colon P. Oof. Boy, that's rough. I sure like to not do that. What if we declare the type over here? Say U32. Flat. U32 is not an iterator. Oops. This needs to return an iterator. Oh, so the map, yeah, it would be down here. It knows these are U32s. trait product map is not implemented for U32. Well, there's your problem. The trait bound U32 must be a product. Yeah, so why are we trying to take the product of a U32? We are not, are we? Okay, so this gives us each of the windows, right? So we're going to say, what did we do before we had window values? Let's make window values. Window values. This needs to go in here. Map. Window values equals window rows dot iter row j as U32. Good. And we want window. Okay, so for each of those windows, we want window values dot product, just like above in the horizontal version. Oh, then we need to get rid of that semicolon. Okay, cool. Whew. All right. So now let's add a meaningful test. It's going to look just like the horizontal one. Horizont becomes vertic. That fails, of course, because this doesn't happen to be. But 0x, I don't know, what's a good mnemonic? Dead beef was very common when I was coming up. I know the Java folks use sometimes Cafe Babe, but dead beef is kind of unnecessarily morbid, I think. And Cafe Babe is not, well, that's all right. We're going to make this 8675309 for now. There we go. Anything just so that if we see it, we'll know it was a, in fact, let's do that. Base 10. Yeah, good. So now if we see it, we know it was a test value. All right, so we need, what do we need? Yeah, we need this. We need the products of all the columns. Okay. Okay, there we have all the columns. Oops. Get rid of all the square brackets. Put these on a row just for grins. Okay, there we go. We've now transposed the matrix. Right, all the things that used to be columns are now rows. And so we want to turn those into stars. And we're going to debug each of these. Okay, and let's run our program. Okay, so obviously the biggest one is this fella right here. Okay, whatever that is. Okay, cool, and it passes. So, redo, we did implement vertical products. Oops. For Euler 11. Push. Euler 11. Okay, what's up next? So now we get to do diagonal, which turns out to be two separate functions. So let's say, how is this going to look? This is going to be, so we have our max, we have our and then. It's actually going to look a lot like this, right? So it's going to be and then whatever we have so far. I'm going to call this R, M. Let's call this M, just for max. Maybe I should call them all M. No, that would be terrible because we'll have M dot max M. Okay, so this is going to be horizontal, no, horizontal, diagonal products. That's nice. That lines up well. Delete dot max dot map d. We'll take m dot max d. Good. Not found in the scope. Of course not defined yet. But it's going to look an awful lot like these. Products of all diagonal windows, like the n in rows. Yeah, maybe rows should be called grid. Leave it like that for now. Okay, so this becomes diagonal products. Let's get rid of this. Put our little dummy placeholder iterator. Cool. These are not yet used. They're going to be used momentarily because what we need to do is diagonal is actually diagonal products. Diagonal down products. It's downward diagonal products. Of the same parameters. Rows len dot max. Oops. Yeah, dot max, right? And then we take that. And then D for downward. I give these all 2-letter abbreviations. It's a little wacky. And then, okay, so we're going to take our downward diagonal products. Upward diagonal products. U. Oops. Meaning max and then D of the same arguments. Dot map, right? Oh, and then it's basically flat map. Dot map U. We'll say D dot max U. Expected expression. It's semicolon. Okay, not found in the scope. Yeah, of course not. Not yet. So this is going to be downward. And we'll put our little chunk in here. And let's do the exact same thing for upward. Okay, expected option found map. Oh, because max, because I have to call dot max. Okay, bunch of stuff's not used. No kidding. You don't say. This one should be using them. Upwards not yet. Downwards not yet. Okay, good. So let's do our downwards. We're going to say, we said we're always going from the rows first, right? Good. Meaning that the columns iterate more quickly. They're in the inner loop. So we're going to say, yeah, actually it'll be the exact same thing as when we go through our vertical products. That'll give us the right set of rows. And then within that, we will need, we're going to need a set of coordinates. We're going to need chords equal. What are they? It's going to be we'll need the windows. We'll need the what we really need is a little rectangle, right? Because it's going to be, like if we're looking in here, the first one's going to be 1, 2, 3, 4, and 1, 2, oops, 1, 2, 3, 4. So it's like that box that we want to analyze. I'm kind of tempted to just do the arithmetic and go with indexes, since I think we're gonna need them anyway to pull out all the values. It seems like we should be able to make do with the rows, as we did for the vertical products. We'll try that. Okay, so we have the right rows, and now we just need the columns. So we'll say, before, we walked through all the columns. Oh yeah, now we're going to do something very similar. We're going to walk through almost all the columns. This is where I got it off by 1 before, minus len. This has to be included. Right. Right, because if you had a window length of 1, you would want to try starting from even the last column. Okay. So now this gives us all of our starting positions. Okay. So we need, what do we need? Within these rows, we need the diagonals beginning from that j. So we need j dot dot j plus len. Those are the columns. So we're going to say window rows, right, dot here, dot zip. So we're going to zip the rows with these indexes. Okay, so now each row, pair each row with the column we want from that row. Okay. So now we're going to, okay, we're already in a flat map, good. So we're going to take, this gives us, for each of those pairs we have a row, reference to a row, and we have a column. Map J. How do we feel about hiding J here? I think I feel okay about it. We call this one J0. K, we can call this inner one K. But we already established we use J to represent column indexes. Okay, we're going to call this J0, like J naught. J naught plus length. We're going to map it over, oh yeah, doesn't like that. Fine, okay, row helps is intentional. Yeah, that's still not used, okay. That row, we'll say, so we need the row at J, right? As U32. Okay. Oops. As U32. Okay. Flat map that must be used. Good. Let's add some comments. Vol downward sloping diagonals length n. Let me get rid of it as rows. All upward sloping diagonals of length n. Okay. Yeah, I really want that to comment the zip. That's okay. Row J. Okay, so this gives us, what does this give us? This gives us the values. This gives us let window values equals that. Then we can say window values dot product. Outlive borrowed value len, because closure. Yeah, this is an odd thing. It looks like I'm just now understanding this, that the Rust compiler messages, error messages, the diagnostics, they underline the parameter list to mean the entire closure. They don't really mean this particular variable. It's not that window rows may outlive this borrowed value. It's the closure. That's a little tricky. It is borrowed here. Yeah, the issue is right here. The len is in use, but len is a parameter of this function. So we're going to put move here. Oops. Good. And for it to be a mute closure, variable captured here, returns a reference to a captured value which escapes the closure body. How do you figure? What if we move it in here? Does that make any sense? Yeah, there we go. Okay. Sometimes you just got to roll with it. And watch that'll turn out to be a bug. It must be very frustrating to watch somebody live code like this if you can see the errors that I'm missing and you just have to wait for me to figure it out. Get it through my thick skull. Okay. So, but we're gonna add at least a test for this now. Let's add a test diagonal. No, wait, we'll do test downward diagonal products. Okay, and we want this to be vertic becomes diagon. Why is that not failing? Oh, because I still. Oops. Horizontal, horizontal, vertical, vertical. Oh, because I still don't have downward diagonal products. There we go. And now we have a failure. Okay, 1788696. Oh yeah, let's make this our test value so we can see which is which. 75309. Okay, good. 7788. So is that in fact? Oh yeah, there's only one downward diagonal product here, right? 2663, because there's not enough room for any other diagonal except this main diagonal. So what was the in the problem statement they told us? It's this. So that's what we're looking for. Now it looks similar at a glance. 17, yada yada. Okay, cool. So what did we say before? Implement downward diagonal products for Euler 11. Okay. Downward. Yeah, we need something just like this, but called upward. And we have the signature down there. Okay, let's just implement it. Haha, let's just implement it. Yeah, it's going to be the same thing for the rows. Windows is quite nice when it works for you. It's just it's probably a matter of practice to just get used to using it. Variable. Yep, good. Into iter. All right. It's not an iterator. Yeah, okay, because flat map wants the closure to return an iterator. So here, in fact, if we did, we could probably do the same trick here. We should make a macro for this. Try to get things closer to an explicit return type. Oh yeah, of course not, because it doesn't know what this empty array is supposed to be. 42. This is intentional. Oh yeah, no, that's not used. Fine. window rows will let me. I'm just curious. Yep, it'll let you. All right, but here what we're going to do is we're going to say, so it's going to be the exact same thing as we had before. Oh, but we want it in reverse. So before we were going from 0, meaning the width minus length. Right, we're going left to right. So the windows are going to be going top to bottom. This window rows is going to be in top to bottom order. So we wanted the corresponding column indexes to go left to right. So top to bottom got paired with left to right. Now we want top to bottom to be paired with right to left. We want top to bottom, so we're definitely going top to bottom because that's how Windows works. Or we just reverse this. Will that work? No, it won't, because it won't reverse the individual windows. It won't reverse the individual windows. I wonder if we can take window rows and reverse that. And then this would be almost the same function. Let's try that. I don't love doing the copy paste here. It seems like we should just do the math right. Wow. Okay, so instead of window rows.iter, it's going to be window rows.iter dot reverse. Can we do that? Reverse. See, iterator rev. Cool. Reverses an iterator's direction. Double-ended iterator. This should be a double-ended iterator. It came from a slice. Dot rev. And for a type of, oh yeah, let's get rid of this. Why doesn't it like that? 96. Window values dot product. Huh. Why did we not have this issue? Oh, because we had a... Oh, that's odd. Huh? Oh, because it's getting it from the turn type probably. Yeah, there we go. Well. Okay. Seems like we should factor this stuff out. Rows go top. Well, I'm just going to leave that. I don't think that the comment would necessarily clarify the code. If you can't read the code, I think the code is as clear as it's going to be. I just wish it wasn't basically duplicated. Well, we can decide if we want to come back to that. Feel free to leave a comment. All right. So diagonal products is the downward one, then the upward one. So let's get rid of our placeholder there. Option U32 is not an iterator. Oh, why do I have... yeah, because I shouldn't be taking max here. It should be downward diagonal products. Oh, and then it should be the upward diagonal products. Did I have the... Oh, no, because diagonal oh. Yeah, actually, I shouldn't need to call max here. What I should need is downward diagonal products. I just need to concat these. There's an iterator that does that, right? There's like a combinator that... is it chain? I think it's called chain. Iterator chain. Structure is created by iterator chain. It takes two iterators and creates a new iterator over both the sequence. Sweet! All right, so dot chain. Haha! Excellent. In fact, this might get us out of all of this and then crap. Yeah, you know what we can do actually? Dot chain vertical products. Oh yeah, this is the way to go, my friend. Diagonal products. Dot max. Dot expect. Right on. At least one window. Okay. In fact, I'm tempted to get rid of the diagonal products one there. It's just... It doesn't really pull its weight, does it? some more stuff to test. Okay. Dot chain. This becomes, I called them len in there instead of window len. I'm just going to call these window. Okay. Expected yada yada. Oh, because these need to be borrowed. Window length. Okay. So that passes as far as it goes. Why is it not yelling about diagonal products not being called? Oh, because I didn't get rid of that one. There we go, cool. All right. So let's test our upward diagonal products. Just for completeness. Upward diagonal products. Upward diagonal products. Actually, none would probably be a better test value here. Good. One's failing. So, oh yeah, there's only one upward, so it's 20 times 17 times 94 times 67. Echo 20 times 17 times 94 times 67. Thank you, Vim. Is this number? And sum. Cool, and that seems to pass. It's going to be basically the same message as this. Oops. Oh yeah, for anybody who was curious about, earlier I was having an issue with when I select a value, I was getting the tmux pipe, which is an unfortunate thing to copy to then paste into the Euler answer box because I don't want it. So I had forgotten, we have there's a bunch of different copyable things here. Euler 11. So there's, of course, the Vim selection, but then tmux has its own selection. So I can like this. So we can select stuff with this. And you can see the tmux selection knows where that bar is. Vim and tmux both understand what's going on here with the terminal. And then I also have iTerms, the terminal's own selection, and that's the only thing that doesn't know where this bar is. So you can have 3 different selections, which is maybe a little bit much to juggle, so I just don't ordinarily use 3 different selections, because why would I? But the right way to select these answers to paste into Project Euler, if I'm going to use the mouse to do it, is just use the tmux selection, which is the yellow one there in the middle, lines 17 through 20 in the Vim buffer. And instead of using the terminal itself to select. All right, cool. So where were we? Oh yeah. So what I want is this message. Meant upward diagonal products for Euler 11. Push. All right. Let's see if we get an answer now. That actually should be it, right? All we need to do is run the program. Cargo run -- bin equal Euler 11. Okay. So yeah. So now what I do is I just select that with the tmux selection, which is as simple as not holding down the Alt key. Okay. Come on. I'm rooting for it. Hey, there we go. All right. Thank you very much. Back soon for Euler 12.